Hi everyone, welcome to our 14th live session. Today is going to be a long one. Hopefully we will be able to cover everything. So we're going to start by seeing how we can integrate orcs with other code bases or like other engines as well. We are going to talk about the new trigger module that has been added recently. And we're going to see how one can extend orcs without having to modify the engine. So there are two main ways of doing this, either with plugins or with extensions, and we're going to cover both. We're also going to see how we can do hot swapping of plugins if we have the time. So let's get started. This time around, I chose a library that I heard a lot of good things about it. I've never used it myself. It's called raylib. It's a C library. I chose it just because it's a C code base, so it was very easy to integrate with orcs. But you can do the same thing with Unreal or any engine that allows you to write C or C++ code with them. I'm less experienced with Godot, so I didn't know if it was easy to write your own C++ at the beginning or like start custom C++ code at the beginning of the run of the engine. But if you can, there are no limitation. You should be able to use orcs with any engine out there, or even any other code base. If you need to, like, I don't know, like rely on the config system in an application that is not a game or something like this, you should be able to get orcs going on with this. So we're going to start by building orcs, and this time, instead of just building the three usual configuration, which are release, profile, and debug, we're also going to build the core one. The core one are going to create a static library instead of a dynamic library, usually done with orcs. And it's also not going to compile any of the plugins. So there won't be any plugins for keyboard, mouse, joystick, render, sound system, display, and physics. But all the other functionalities are going to be there. It's just that we're not going to be able to leverage any of those plugins. In this example, I'm just going to use the config system and the local system just to show you how it can be done. So we're going to start by building all the different versions. It's not going to take forever. The advantage is that orcs usually compiles in 1 to 2 seconds on my machine. So that's core debug is done. Core profile, going with core release. So now we have all the static libraries of orcs made, and I'm also going to do the regular dynamic with plugins, just because we're going to create a new project later on to test the trigger module. So might as well build everything now. Almost over. And the last one being release. Well, there we go. We built all the 6 versions from scratch. We can put this away for now. So I'm going to open a vanilla clone of Relib, which seems to be like a very solid, rather low-level library for making games and multimedia applications. And we're going to, I picked one of the example. This one is called text format text. That's just going to render some text on screen. It's very simple, and it's a perfect playground to show how to integrate with orcs. So if I run it, hopefully you see, there we go, we see the example, and it's basically just printing some values here. We can have a look at the code real quick. You can see that it's a fairly short source file. Basically, we are just creating the window, which I believe is where the relib initialization is happening. Setting some target FPS, and then we have a main loop where we, so it's a low level, right? It's not like an engine. You have to issue your own draw calls. You have to do everything. It's definitely a framework. And so here we just start for each loop beginning to draw. We clear the background to white. We draw a few texts. We stop drawing. And we loop until we should leave the application. And then we close the window, which is probably where relib cleans everything. So how to integrate orcs? Well, there are 3 steps to integrating orcs. The first one is to make sure that the compiler knows where to find orcs, right? So, because if I were to include orcs, and including orcs is very simple, it's include orc.h. There we go. If I were to try to build this one, you see that it cannot find the include. So we're going to modify the project. We're going to go to the property. I'm sorry if it's a bit too small on the screen. I'm not exactly sure how to zoom this one in Visual Studio, so we might have to pause later when watching the video so that you can zoom in. Basically, we're going to go to the C++, making sure that we affect all configuration. Here we have additional include directory. We're going to add the aux1 at the beginning. So $aux /include. There we go. That's for the includes. We need to do the same thing for linking the library. So same thing here. We have the general. We're going to say additional link library. It's going to be aux lib, and this time we want to try the static one. You can do it with a dynamic if you prefer. It's just that to showcase how to use a static library, I'm using this video, this live session as well. So aux lib static. I'm sorry, it's tiny on my screen, so hopefully I didn't make any typo. And we're going to say, well, link with aux. So you could try to link the debug version of aux for debug configuration. Right now, I'm just going to use the release version of aux for everything, just because it's much faster to showcase how it works. So we're almost done. The last thing we need to do is that if I do this like that right now, it's going to compile this time because we're not using aux yet, right? Let's say we wanted to make a call of aux. Let's see how it goes. So initializing aux, we're going to create an init aux function. And for exiting aux, we're going to create an exit aux function. I'm just doing this so that it's cleaner, or at least more clear when reading the code later on. So we have an init aux function, and we have an exit aux function. And you saw that all we have to hook are the initialization and the cleanup of the engine. And that's all we need to hook for it to be functional. And how does this work? The first thing we need to do is init the debug of aux. And the last thing we're going to do is exit from the debug of aux. This has to be a separate step because debug is going to be used all throughout aux for all the logging purposes. So this needs to be done first. That's the only hard requirement for using aux itself. Then after this, you can decide which part of aux you want to use. And you can decide it even like later down the execution cycle of your program. You don't have to do it at the initialization. Here we're going to do it at initialization because it's more clear. But if at some point you need to use a config only for like a very specific part of your execution, you can do it at that time. You don't have to do it ahead of time. So here, for example, we're going to use the config first. So I'm going to ask to initialize the config module. So module ID config. And same thing, we're going to exit from it at the end. And there we go. Now we have access to everything configured in aux, and all the dependencies of the config module are also going to be available. So that means that we're going to have access to memory management. We're going to have access to threads, to resources. There is a dependency tree made inside aux, which will make sure that all the necessary modules are going to be initialized when you request one. And same thing when you're going to exit from the functionality you don't want, all the things that were loaded behind the scene or initialized behind the scene are going to be freed as well. So if I were to do this and try to execute, you'll see that it's not going to link. We have a few errors. Just by default, when we write code with aux, it expects to use the dynamic library version of aux. Here we're going to use a static library. So we have to tell the compiler that we are working with a static library. And for this, it's very simple. You go to your C++, you're going to preprocessor, and you're going to add the __ aux static __. And that's it. Now, when you're going to build your code, it knows that it's going to use the static version of aux, and you can see it built and it ran. So far we have integrated, we have literally integrated aux with a foreign code base that is relying on a different engine or library, and we can use aux as we want. So because we're going to use the config system, we will create a INI file where we're going to put some data and see if we can fetch this data. Oh, and by the way, Let's see. This is where the executable is. Here you can see that it's 1.05 megabytes. If I were to not use args, so let's go back to where we were before using args. There, we're not using args anymore. You see that by default, the executable is 457 kilobytes. So that means that the entire engine without the plugins is about, the footprint is about 620 kilobytes on Windows. Your mileage may vary a bit on other platforms, but it's going to be around the 600 kilobytes for the entire engine minus the plugin. So it's fairly reasonable, especially in 2024. When you're going to integrate with any code base, 600 kilobytes is probably, very likely, not being any concern for anyone anymore. So yeah, you don't have to try to cut args into smaller chunks because the entire engine fits in 600 kilobytes. So let's go back to having this. And here we're going to create a config file where Relib executes its code. And I believe it's in example, and this is a text example. And yeah, so here, this is the folder that's going to be the working directory when running the application. So we're just going to create a new file, and we're going to call it text.ini. There we go. And because I have Visual Studio here, might as well use it as an editor. Let's create a section called strings, and we're going to, what are we doing actually in this? We're going to replace those like iScore and lives. We can add like data to pull those strings instead. So let's say like, for example, we have iScore, but we want to actually print iScore like this. So this is a config file. It only has like one section, one key with one single value. And here we're just going to say, okay, first we need to load the config file, right? We're just going to do in the initialization. This way it's done. So orgs config load text.ini. There we go. And here we're going to replace this by pushing the section, config, push section, strings. We're going to pop the section here. And here, instead of iScore, we're going to print orgs config get string iScore. So if I did not make any mistakes, now we should see iScore in two separate words. And you can see it's working. We have high score. So there, that's it. We integrated orgs with a different application. Let's try to push this example a bit more because why not? So instead of just relying on the config, let's also rely on the localization system. So we're going to, once we're done with the config, we're going to say, okay, I want to initialize orgs module ID local. There we go. And we're going to exit from it. The order of init and exit don't really matter because, again, we're maintaining an internal dependency tree. So you don't have to do like inverse init versus exit and things like this. It doesn't matter. Okay, so we now can rely on the localization system. Let's actually group them together because we're going to do some timing after. So here we initialize those modules. So I think it's pulling probably another dozen or so sub-modules. We can actually verify this by putting a breakpoint. And we are not hitting the breakpoint because we are in release. Okay, you know what? Just for the sake of this exercise, we're going to put it here, put the breakpoint here. There we go. We're going to get inside it. We're going to put a breakpoint in the module initialization, and we're going to see which module are going to be initialized. So we initialize config at the moment, which is going to pull in bank, memory, profiler, system, thread, command, event, file, string, resource, config finally, and then local does the same, but local depends on config and the other same dependencies, so it's not bringing more things. So we have about a dozen systems being initialized. So orgs is made of 50 systems, so it's not the entirety of the engine. It's only the part we need. So let's go back in where we were here. So yeah, we were doing localization. Let's modify a bit our config system here, config data here. So let's say that we have two languages. One is going to be English and the other one is going to be French. And I-score in French is going to be meilleur score. Voilà. And now we have two languages with one single key, and we can use it here. So we don't need to push a section anymore or popping a section. I'm going to remove this. And here what we want to retrieve is aux local get string. We still want the I-score 1. We don't want a specific group. And that's it. So the only thing that needs to be done now is selecting the language we want. So let's say that aux local select language. If we were to select English for all the groups, we should get still I-score. I'm going to remove the breakpoint. It's I-score, and now if we wanted to select the French language, we should get meilleur score. And as you can see, we have localization supported in our really big example, just as easy as this. We can actually even move the language to data here by just saying the local. We want the language by default to be French. And here we can remove this call here. The only thing is that we need to initialize local now after loading the config. Otherwise, when the localization module is going to be initializing, there is no actual data. It would not be able to find the French language. But if we do this, we should still see the meilleur score here in French. That's about it. Let's go back to where we were with selecting here, and we are going to do some timing. So in order to do this, one easy way is to use the C++ chrono. However, as you can see, relib is a C. It's not going to compile in C++. Just for the sake of this exercise, I'm going to ask Visual Studio to compile in C++. So by going to Advanced, we can ask compile C++. It's going to be basically virtually the same executable, except that we have access to C++ now. We are going to use std chrono system clock. Why use system clock? Clock. There we go. We're going to use std chrono duration cast, and we're going to use std chrono. We're going to do all this in microseconds. Okay, let's go and let's do it. So auto start equals system clock. Now, now, there we go. And then we're going to take another time just after it, stop. And we're going to print this. So print f, let's call it aux init, microsecond, going back, there we go, and make it pretty, well, prettier. So what we want here is a time, and for this we're going to have to cast it as an int. We need to do a duration cast in microseconds of our stop minus start count. What? There we go, count. And this should print the timing for how long it took to initialize aux. And when it's about 2.6 milliseconds at the moment. And we're going to do like a similar thing with the exits. So start, stop, and aux exit. Oops. I know how to type. And we're going to do the same thing with relib. Oops. Sorry, a bit of copy pasting there. Probably not the cleanest way of doing it, but you know what? I could have put all the timing here. Yeah, it doesn't matter. It's okay. Anyway, so start stop. We want to put the init window in it, and this is relib init, and then finally we want to do this for the exit, which is a close window here, and we want to put close window in it, and that's going to be relib exit. come on, exit, and okay, redefinition, yes, of course. There we go. Okay, so now we have timing. It took this time 1.8 milliseconds for arcs to initialize, and for relib it took about 230 milliseconds. Keep in mind that relib needs to open the actual window, and most of this time is probably spent in the logs we see on the command here and the window. I'm pretty sure relib is also as fast, if not faster than arcs, because it's probably initializing even less things. So all this to say that it's a matter of milliseconds. And actually, you know what? Those are timing taken with Visual Studio attached. Let's see without attaching Visual Studio. And you can see arcs is more like close to 1 millisecond for initialization. And relib is about less than 200, and for leaving, it's 10 milliseconds for relib, again, because probably they are closing the window and it takes time in the OS. And leaving arcs is about 0.4 milliseconds, so the overhead is, like, I would say, negligible. For initializing many systems in arcs, it's about 1 millisecond, and for leaving arcs, it's about 0.4, 0.5 milliseconds. So it's virtually completely unimpactful on your execution. I think I timed initializing arcs with all the plugins in and creating a window. We were about 250 milliseconds, so like very similar to relib. So in any case, it shows you that adding arcs to your project, no matter the engine you're going to use, the overhead is going to be minimal. It's going to be 1 to 2 milliseconds for initialization most of the time, and less than 1 millisecond for leaving. And it's going to be 600 kilobytes of disk footprint. And memory usage is also minimal without the plugin. I think it's a few megabytes at most if you're using debug, and in release it's probably a few dozen or 100 kilobytes and max. So to summarize, we need 3 steps to integrate arcs to any code base. The first one is making sure that your toolchain knows where to find arcs by adding the include and library. The second one is to actually initialize arcs. And so you need to include arcs. You need to call debug init, debug exit, and then in between you can initialize any module you want and use arcs the way you want it. And yeah, so the third step is just using arcs. So that's it. You make your arcs call anywhere you want. If you rely on the clock, you will have to initialize the clock module as well. Actually, let's do it real quick. If we wanted, for example, to have some timers or like any time callback and things like this, we would have to use the clock module, so both init and exit. And we would have to make sure that in our loop somewhere, we just call arc clock update. And that's going to be the thing distributing the work and all the callback everywhere. And hopefully this is still going to be running just fine, except that now if we had like any timers or any registered function, they would be called from the arcs clock update. And that's all you need to do to be able to have like a fully working loop inside arcs itself if you wanted that. And that's it for integrating arcs. Are there any questions on this?
So far, I don't see any, but if any come up, I'll let you know.
Okay, perfect. Thank you very much. So right now, I'm just going to close this one, and we're going to move to the next one. Yeah. So let's close this. And now we're going to create a new application. So in live, we're going to create live 14. We are going to create it with a default extension. Remember, if you type help, you will have all the extensions that are available. And by default, we are getting both scroll and bundle. And we don't need anything specific because we're just going to test the trigger system, which comes inside Arcs anyway. So creating live, going to live 14, build, Windows, Visual Studio. Okay, and it's called live 14. There. So let's build the debug. Oh, and because we are streaming, let's make a few changes, the same as usual. You're probably used to this. We're going to not ask for, okay, not doing this. We're going to have for screen width, we're going to match the one from the camera. Frustum width, and screen height is going to be camera Frustum. And here we're going to go in 1080p. There. So the last thing we're going to change so that you can read the console is render. No, that's not it. It's render, sorry. Console font scale and 3. Let's see if this builds and runs. Oh, and I forgot. Oh, it actually picked the right monitor. The console is big, so just to make sure that it will always be on the right monitor, we're going to ask it for monitor, second monitor. There. So all the execution will always be on this monitor. Okay, we have it working. Let's play a bit with the trigger. So actually, as you will see, by default, there is a trigger list already in the object, and let's look at it. So we have one new thing that's been shipping with orcs lately, or scroll actually. If you have a scroll object, you can define inputs for that object. So that means that these inputs can be your unified way of interacting with an object, be it from actual physical input. If you want a player to be able to move a character or an object, you can bind it to physical input like the keyboard, the gamepad, the mouse, or you can actually use code or commands to handle those virtual inputs and have like an AI pressing virtual buttons. And that also allows you to bind physical inputs to those virtual for like testing animation on an object or something like this. It's a very powerful debug tool. If you are not familiar with this, you can go back to one of our first live session, which is all about virtual inputs. Except that back then we had to do it manually. Now it's a baked-in functionality inside Scroll. So any Scroll object will have a virtual input interface available if you request it. If you don't request it, it's going to be deactivated. It's not going to use any runtime. But if you request it, it's available for you. And the way to request it is simply by specifying the input property. Actually, if we look at the extension template here, you can see that for scroll object, there is one that has been added, which is input. And that's basically the section where you want to define the input. Here I say we're just going to stay in the same section. And I bound both key space and mouse left to an input that I named back. So by just this and not doing anything, if we were to like trigger the back input, nothing would happen. However, here, because we have a trigger list, so actually, you know what? Let's run it without the trigger. So there's no trigger on this one. If I were to click on the mouse or pressing space, nothing happens. The input have been triggered, but because nothing is listening for the back input, nothing happens. We can change that with a trigger. Here we have, just for scroll, we have a trigger that is being created that's called OnInput, where we can listen to input. If there's a dot before the input, means that we're going to listen only to the activation of an input. If there's no dot, means that it's going to be activated as long as the input is enabled. If there's a dot minus, it's going to say the first frame of the activation. And if there's just a minus, it's all the frame of not being active. So with this, we can drive some simple logic, which can be handy for like transition, for debugging purposes. And let's see how it works. So basically, I created a trigger list. I have a single trigger that I called reverse. And I mean that in the reverse section here, I define the trigger called onInput, and I'm going to listen to the first activation of back. And the first time that back input is activated, I'm going to execute that command. This command, as you can see, just retrieves the current angular velocity of the object. It's going to reverse it. It multiplies it by -1. And then it's going to set the angular velocity on the object again. So basically just changing the rotation direction. So if I were to run it and press space, you can see that now the object is changing rotation. And even if I keep space pressed, it's only at the first activation that something happens. Same thing if I left click. And now we have the combo of triggers with input. So let's build upon this and see what we can do with these kind of things. So For this, we're going to reuse some assets I used in the past. I'm going to link the author in the comment. I don't remember from the top of my head. But if you remember, it was the king human, the king pig, and the pig. So I'm going to bring those assets as is without any pre-processing inside our live 14 folder here. Data, texture, going to paste it here. We don't need the logo anymore. We're going to get rid of the logo and the sound. So when we're going to create the scene, we're going to delete all the content that was below. So right now we have an empty scene and Orcs is just like going to run with a black screen and nothing happens here. Let's see what we can do. We have multiple characters. Let's start with the king human. We're just going to use the idle animation for now. We can see that there is an idle here and the frame size is 78 by 58. So let's start by creating our king. So we have king, we're going to create king as an object. And remember here we have like, by default, we have an object class that's bound to the object section, and we're just going to piggyback on this. But actually we didn't need to. We could have done it with a plain all scroll object as well. That would work just the same. So animation set is going to be itself. We want our start anim to be idle. What else do we want here? We want the key duration to be 0.1 seconds. We want the frame size to be, I forgot what it was for the king, 7858. 78, oops, 58. Okay. So that's a king animation set. Start anim. Let's put a pivot center. Do I miss anything besides having the animation now? I don't think so. You know what? Let's test it. So idle is going to use that texture we saw earlier, and we're just going to copy paste the name. Oh, and we're also going to go inside the right there folder, and the name of the texture is this guy here, .png. We don't have, yeah, we have the frame size, texture, idle, king. Let's see if this works. It does work. It is tiny. Let's change this at the, you know what, we are just going to zoom the camera this time. So zoom the camera, I don't know, 4 times maybe. Yeah. And we see our little king with its idle animation. That's a good start. Now we're going to have a different character. Well, so to showcase this, I was thinking of having the king that can either die by one type of damage or being changed into a pig by another type of damage. So what we can do is just starting with testing our animations. So we're going to also have like a death animation. So from like put it here. So from idle, we can either loop on idle, or we can go directly to, let's call it die. And from die, once we're over with die animation, we're going to loop on the dead animation because we don't want to like keep playing that animation over and over and over. And dead, well, dead is just going to loop on itself. It's going to be a single frame. So idle, we can loop on idle, and if we die, we just end up being dead. So here we're going to have, we already have the idle, we're going to have die. The texture of die is the dead animation. There we go. And the dead one, so the dead one, it's a bit different. We want the same thing as die. So remember that now we can inherit from animation section. It's a feature that's been added in the last few months. So we want the same thing as die, except that, oh, you know what? We are not going to do it here. We're just going to say we want a single Well, we're going to keep it here. We want a single frame. So here we say that, oh, plus I made a mistake here. Let's die. There we go. And we say that dead, it's a single frame. Except that we don't want to be the first frame, we want to be the last frame. So an easy way to do this is just changing the direction. Instead of going from left to right, we're going to go right to left, and top down doesn't matter because there's only one line. So we're going to take the last frame as the dead frame, and it's going to loop forever on this one. So here I should have a proper animation set with all the transition. So one way to test it would be to open the game using the console to find the object. It's called king, and then playing the animation on the king and say I want you to die. And okay, because I made a mistake, so find king. There we go, I want you to die. And you can see that it's been dead, but something was wrong. It came back to life. It's probably because there's no more animation. So we can see here that there's an invalid direction value for anim. So probably I made a mistake here. It's being ignored and can't evaluate command line. Oh, that was my mistake in the console. Couldn't complete next animation when trying dive toward die. So die goes to dead. Oh yeah, because we want to try to continue being dead. Trying to continue having the target animation being die, we want to erase it when we do the transition. So this should fix our issue. And here, if we go dead, it stays dead and it's fine. So that's one way to test it. But if you have like plenty of animation, using the console might not be the most appropriate. So we can actually use the input system for this. And let's say that we want input. We're going to use self as input. And I don't know, like key space is going to be die. So here we define the input die, and we're going to add a trigger. So all this we could put like as a debug section if we wanted. We will do that in the later for like resetting the application. So here we have a trigger list. We can say ourselves as well. And on input, when die has been activated, object set anim die. So now if I launch it and if I press space, we can verify that the animation is working. So it's much easier to test like this because I bound it to physical input and I can bind it to any keys or any buttons. So this kind of debug is definitely very useful. It could be like in its own debug.ini, and I would just like I would have to put back king here. But if I were to copy all this in its own dev.ini file, it's something I can test locally and I can remove when I don't want to test anymore, like now. I don't want this test anymore. But it helps me to like test all the animations if I wanted to see if I made all the transition correctly. And I can do that with any object, even if those objects are not going to be driven by a physical input later, it will still work this way. So now we're going to create a cannon so that we can shoot our little king. And you know what? Our little king, we're going to move it a bit to the left. There we go. And we're going to create a cannon. Oops. We do have a cannon, there it is. Idle is a single frame, doesn't matter. And a shoot is a 4 frame. We're going to use this as well. So you know what? We could do a bit of refactoring, like having idle, defining the center animation set and all this. We could put it at the object level. So let's do this actually. Let's see that all our objects, by default, they are going to be using a 10 Hz animation, and they are going to use a centered pivot by default. They are going to play an idle animation, and we will be able to have cannon inherit from object. And this way we already have all this set up. We need to change a bit the idle, the die, and the dead, otherwise it's going to affect both the cannon and the king. So for this, we're just going to define a prefix. So we can also put this in the object itself. We're going to say that the prefix is going to be itself. So basically, if I'm inside king, the prefix is king. If I'm inside canon, the prefix is canon. And I can define this at the parent section. So what else do we want to inherit? That's about it, I think. So we keep the position, the frame size, all these. The new transition, the idle to die and die to dead, is specific to the king. And we're going to just override this for the king with a prefix. So king die and king dead inherit from king die. There we go. So we have the king here, and we can actually like future-proof this as well. We're going to have how do you call a pig later down the line, right? So we're just going to create a character class. So character inherits from object, and everything that characters shared, we can put it here. So what are they going to share? They're going to share the fact that they can actually go from idle to die and from die to dead. This is a character. It's generic to all, common. Sorry, it's common to all the characters. Sorry, my English is terrible today. Okay, so let's verify this still works, by the way, if I didn't break anything. Yeah, all good. Excellent. So now we need to define our canon. We say that the canon has an idle. Canon idle. It's a single frame. So I'm going to copy this. And the frame is named idle and it's 10-canon. So 10 canon idle. Because it's a single frame, we do not need to define the frame size. By default, the frame size is going to use the texture size. So with this, we should have like a canon that should be sitting a bit to the right. So position 100. And let's add it to our scene. We want a king and a cannon. There we go. We have a cannon now. The cannon can shoot. So it's something specific to the cannon. We're going to add it here. So instead of having the default idle transition, we can loop to idle, or we can interrupt directly to shoot, and we want to shoot just once. And once we're done shooting, we always go back to idle. It's a single shot. So all good. What we need to do here though is canon shoot. We want to define the texture. Texture for the cannon is this guy there, and we also want this time to tell that there's a frame size, which is apparently 4428. Okay, so we can now shoot. And what are we going to shoot? We could shoot a cannonball. We're going to create after. Let's verify that our cannon can shoot. So object, I could have used a trigger. Let's do it this way for now. Cannon, object, set animation. On the cannon, shoot. And it can shoot. There we go. This is working. So we want to create a cannonball. So cannonball, it's going to be an object. And it's only going to have a single idle. Cannon. I could remove the animation, but because my object have an animation by default, I'm just going to use an animation as well. So cannonball idle, and the texture, oops, and the texture is called cannonball. Okay. Now for this cannonball, we want to say that the lifetime of the cannonball is probably going to be 10 seconds. Why not? We could use a spawner, to like decide how fast the object is going. Right now, because it's not the point, I'm just going to put the speed directly inside the cannonball. So let's say a cannonball by default goes at 200 pixels a second toward the left. And that's about it. We just need to spawn cannonball when shooting. So if we look at the shoot frames, we would say we probably should spawn it during the second frame, right? So that's what we're going to do here. So we're going to say canon shoot frame 2. We are going to have a key event to create a cannonball. So we're going to object create cannonball. And this object, we are going to set ourselves as a parent so that it spawns where we are. So object set parent of the cannonball ourselves. And just in case our cannon could move, we could detach it. Object detach. So that means that even once it's been moved where we are, we can detach it. This way, if the cannon is moving, the cannonball is not going to be affected by it. Let's see if this works. Let's try to shoot the cannon. There we go. So we need to probably change a bit the pivot. So you know what? The cannonball frame is actually huge. We should probably find the right place for the pivot here. And it sounds to be around, what's 2818. Okay. Let's put cannonball pivot 2880. And let's see how it works. Okay. There we go. Sounds rather good for now. So now we have a cannonball that shoots, except that it doesn't do anything. We need to be able to interact with the king. And for this, we can use the physics module. We are going to use collision for this. And because collisions have been hooked with a trigger, we can detect the collision without having to write any code. So let's get to there. Sorry, there was a bit of setup for all this. Hopefully that wasn't too long. So let's add bodies to these guys. So the king here, we're going to want to do it at the character level. So character level, we are, no, because they have different frame size. Oh, it doesn't matter. So we want a body. Body are going to be ourselves. It's going to be a single part. And the type is going to be a box. We want our self flags to be character. And we want to check collision with projectile. There we go. What else? We want it to be dynamic. And we don't want it to be solid. Okay, so now we should be able to have those. Let's, you know what? Let's put it at the bottom. Physics show debug true by default, so that we can see what we're doing here. Okay, so let's see if we have like a body on the. No, we don't have a body. So what did I mess up? So physics show debug true. That's correct. The king. Oh, the king inherits still from object and not from character. So it could not have died anymore. Okay, so here we are. Now we need to figure out what the dimension are for the kings. So actually, you know what? The pivot should probably be a bit more to the left and down, and it will make it easier to define the position of the box. So king, where are you? King here. King. Actually, I think they are all about the same. So if I look at a single frame, like the fall one, it tells me that the pivot should be at about 3042. Let's see if this works. So king, pivot, 3042. Nope. Invalid direction value for dead, ignoring. Okay, I didn't fix that actually. So king, dead, direction. Okay, it's working, but it says invalid value. So let's go check here. Direction. Not sure what's invalid. Okay, we will address that later. Why is my pivot not working here? Any idea? Sorry, I'm like too close from this. Why is my pivot? Pivot should be here.
Hold on just a moment. I think H. Cardi might have an idea. Top versus up for the direction and animation is their suggestion.
Top versus up. Right. Thank you so much. Yes. Thank you. The pivot is not working. You know what? I'm going to cheat a bit and looked at my at the test run I did earlier this week, and just to see which value I put there. Okay, going to open that project. Okay, what did I have for the king? Frame size, that's fine. Body, I'm going to copy the body. Actually, I just moved. Yeah, okay. I'm just going to copy paste the value I had here. I didn't touch the pivot in this version, so I'm not going to touch the pivot this time either. So you know what? Pivot, object. There we go. I'm just what did I do? Okay, let's see if that match about the king. Okay, we have the collision at the right place. That's basically all we want at the moment, so we're not going to worry about the pivot. And we want to do a similar thing for the cannonball. And again, you know what, because I have opened my cheat sheet, I'm just going to copy paste the property for the projectile. So here we go. It's going to be a bit faster too. This way we're not going to lose too much time on details. So my cannonball is here. And we want a body which has a part list, which is dynamic. By default, it's solid is false, so I don't need to put it. The lifetime is here. Why did I put it on the cannon? Okay, that's not a good start. Cannonball. Sorry. There we go. Lifetime already added. Self flag projectile, check mask character, and we should be able to see a little circle when we shoot. There we go. Okay, so they are colliding, except that we do nothing on the collide. So you know what? Also, we want to be able to trigger the cannon with the key. So we're going to do it with a trigger like before. So cannon here, we're going to say input, we activate them. We're going to say key space is going to be shoot. And we're going to use a trigger on it. We're just going to be ourselves. And on input, shoot, object set admin shoot. This way I don't have to use in the console anymore. I can shoot cannonballs, and this is working fine. Okay, now if we want to handle the collisions, so if we go back to the king, and that's where we're going to add a trigger for this, right? So basically we're going to have a trigger that's going to trigger different animation based on the collision. So let's look for it. Okay, let's see. A second. We're going to do it like this. Okay. We're going to my cursor there. Trigger list. We're going to add two triggers this time. We're going to have a generic collision trigger, and we're going to have one to handle damage. So the collision trigger, we want to handle what's going to happen when we collide with something. So we can have like a generic OnCollide that's going to be a catch-all for everything. And let's do this actually. When we're going to say OnCollide, which is the catch-all for something collided with me, no matter what it is, we're going to like trigger damage on ourselves. So object, fire trigger on ourselves. We're going to trigger to fire the trigger called on damage. We can give it any kind of name. It's just I'm going to stay consistent with the naming convention of having on something. But here you can call it basically what you want. So that means that when a collision is detected, we're going to fire the triggers called on damage. And we're going to define this in the damage trigger, because this way we can put it on multiple objects or NPCs and can be generic. So here in the damage trigger, we're going to say on damage we're going to die. Object set anim die, like a one hit kill. And we could make it like having health point and things like this, but it's going to be too long for this exercise. So we're just going to die. Let's see if this works. So normally, if anything collide with the king, it should die. Nope, it's not working. What's going on here? Path cannonball isn't valid type. Okay, I made a mistake. I didn't put the type for the cannonball. That's what you get for copy pasting things. Type. Sphere. Okay. Let's try this again. Okay, it dies, but the sphere is a bit big. Let me see what kind of value I had for the cannonball on the other one. Projectile. Okay, cannonball. I had this here. Okay. We're going. After saying that it's what I get for copy pasting, I do more copy pasting. So we're just going to have like a pivot and a radius, and hopefully this time our cannonball is going to be small enough. But as you can see, it's going to kill the king, and the king is coming back because we still have the collision activated. So it means that next time we ask him to die again, there is no path in our animation graph to go again to die, so it just bails out. So we need to tell it that when you're dying, no more collisions for you. So easy. We're just going to go to the king dead here, and we're going to say on the first frame of king dead 1, we are going to say we're going to remove your body. Object set body nothing. Let's see if this works. Yep. No more body. I should probably not do it on the dead, but on the die, so that the first frame it dies, there's no more body. There we go. So now if I shoot, it stays dead. I don't want to have to restart everything. So let's look a bit into debug for now. So one thing I could do is having an object that will remain in the background and that will use a trigger system so that I can hook debug command directly and have them executed. So let's do this. If we go to our scene, we're going to create a debug object. So how much time are we? Oh, we're already at 1 hour. We will not be able to look into extending arcs. Hopefully that will be okay for next time. We will just finish this example with like subclassing events and triggers, sorry. And it's probably going to bring us to like the 1 hour and a half mark, but we'll see. Okay, so we have a debug object. Debug object because we're going to delete the scene and recreate the scene, we don't want to recreate the debug object every time. Otherwise, we might end up as an infinite loop, where in the same frame, we're going to delete the scene, recreate the scene, say, oh, there's an input that we need to reset, and so on and so forth, and we're never going to get out of this. So we're going to say that on create, we're going to retrieve a config property going to be the ID of the debug here. And we're going to inherit from scroll object. Okay, so same thing for scene. No, that's just this one. Okay, so get debug ID, we're going to store it as well. So, which means that, how did I do that in the past? You know what? As long as I'm here. Oh, right, okay. We need, sorry, not on create, on prepare. We're going to check, so, sorry, going back in time. When we're going to create the object, we're going to store our ID inside our own section instead of using a runtime section. That's also valid. We could use a runtime section as we usually do, but we can also say set our self ID with our ID. And that means that the current section is going to retrieve the GUID inside the key named ID. On the onPrepare, we're going to check for this just to see if we already exist. So we're going to get our self ID. We're going to check, is this equal to 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Is it equal to -1 as a GUID, which is 16F? And if this is true, then we're going to say yes. So basically, that should be fine. Yeah, let me double check that. Oh no, we need to. Yeah, that should work. I think we can verify that the object is actually alive. So object get ID like this. So basically, we retrieve the ID. Here we run it through object get ID to make sure that the object is still enabled and active and it still exists actually. If the object wasn't existing, but we still had an ID that is not -1, this will still return -1. And here means that, okay, we are green, we can create a debug object. It means that we're going to create the debug object just once and for all. And to make sure that it's not deleted at the same time as the scene, here when the object has been created, we store its ID, but we're also going to say object.setOwner none. So basically, it's not part of the scene anymore, and it's going to remain in memory over time. And this little guy, now we can modify it. We can say, okay, you have an input. It's going to be key backspace. Okay. And we're going to call it reset. And it's going to have a trigger list. We're going to use ourselves again, and we're going to say on input. When reset has been activated, we're going to fetch the scene, so get scene ID, and we're going to delete it, and we're going to recreate a scene. And we need to make sure that the scene stores its ID upon creation. So we're going to do here on create. We're going to do the same thing as we did with debug. So set ourself ID with our GUID. Let's see if this works. So if I kill it and press reset, it's back. So I can reset anytime. And you can see that the cannonballs are not being reset because they don't have any owner. They've been created by no one, and they are just going to stay there, and that's fine with us. We just need to make sure that the cannon itself is recreated. It's been deleted as part of the scene, but it's already, yeah. So king and cannon are going to be deleted, and debug will remain in memory, and our cannonball will remain as well. If we wanted the cannonball to be deleted, what we could do is on create. We retrieve the scene, get scene ID, and object set owner of ourselves the scene. So that means that if I shoot cannons and I reset, you can see that the cannonballs are deleted this time. So it doesn't really matter for this test, but at least we can test more quickly. So that is one way of using the input and the trigger together to have like debug commands. Like the reset debug commands allows me to restart entirely my game, but I can like trigger the display of debug information, some viewport, these kind of things, as easily as this. And that's just like one object that's going to be sitting permanently, as long as it's been created once. It's not going to be recreated again thanks to this little on prepare. And it's going to be just listening for inputs, and when some inputs are made, it's going to execute them. So that's one way to use the trigger system and the input for debug purposes. And this could be like in its own dev.ini or debug.ini or however you like calling it. So now let's go back to the damage. So we have a king that can die if it's hit by a cannonball. Let's say that it could also hit by a different kind of projectile. We're going to create, what do we have here? Let's see. I think we can use a box. We're going to use a box. Very simple item. So, oh, that's why the copy paste didn't work earlier. It's probably because my cannonball, instead of inheriting from object, I probably factored everything in projectile like this. And so projectile. And that meant that I probably had like lifetime there, the speed there. We can put the on create, we can put this, the body, the part list, the dynamic, the pivot we keep there. Okay, type. All this is just for the cannonball. And now we can create a box that's also going to be a projectile. Projectile. And you can see that we're going to keep the body, the part list, dynamic. All this is going to be there. We probably want to put also the mask for that projectile. So check flag is going to be, the self flag is going to be projectile. The check mask is going to be character. And this one is probably going to be just a box. Oops, type equals box. And this time around, this image is actually snug, so we won't need to edit the coordinate. We just need to make sure that the box has an idle, so box idle, and the texture is going to be the box. So it's 08 box idle. 08 box idle. Oops. So now let's say our cannon, we're going to have two way of shooting. If we remember here we had an input shoot. Let's create another one. It's going to be enter for me, and we're going to call it shoot box because why not? And on input shoot box, we're going to create also the same anim shoot, and we just need to figure out which object to shoot when we're shooting, right? So what we could do is we could store it in config, or we could which one is the best? Yeah. Sorry, I'm thinking a bit out loud. Yeah, why not? We are going to, yeah, we're going to start it in config as a projectile. So basically here the shoot, we're going to say also set our self projectile. We want it to be a cannon. And here projectile, we're going to it to be a box. And here instead of creating this, we're just going to retrieve it. So basically we're going to get our name, object get name. Doesn't matter, but I like fixing my case. We are going to get from this the projectile, and that's going to be what we create. There we go. So now we should be able to create both a box and a cannon. Let's see if that's the case. Okay, that's not working. So I made a mistake. Okay, sorry about this. Object get name. Oh, yeah, the at doesn't exist, so it's cannon. I would have to do the same thing otherwise. Get name to retrieve the name of the thing. Same thing. I'm just going to use cannon. Okay, that's. What did I do? Cannonball. There we go. And I can also shoot boxes. So now I can shoot both. And we just need to do something different with boxes. So that's where we can have a different filtering for the collision. So if we go to creation template and if we go to the new trigger, you can see that we can have something called refinements. And we do have some refinements already existing for the OnCollide and the OnPart collide. So we can either filter on the name of the object that's collisioning with us, or we can actually filter on the name of the part of the object colliding with us, and also on our local part. So if you want to have a different trigger depending if you've been touched on your body part versus on your head part to handle like headshot, for example, you would use the on-part collide. I'm not sure what I did there. You would use on-part collide colon head or colon body, and then you can even filter based on if, I don't know, you've been hit by a bullet, if you've been hit by a box, like we're going to do, or something like this. And the way it works is that it's first going to shoot to trigger the event with all the refinements. If once this is done, even if it's not found, it's going to trigger the refinement, the more global refinement. So let's say that here we have, let's go on our OnCollide. OnCollide only has one refinement. So let's say that instead of OnCollide, we had OnPartCollide. We want to say that if we want it to be on the head, hit by a bullet, you know what? Why I could just write it below OnPartCollide. I want to filter things that hit my head, and I only want bullets. So if I define this, when an event is being triggered by a collision between my part called head and their part called bullets, this is going to be called. When this has been executed, it's then going to be found the slightly more generic refinement, which is on part collide head. So if I defined on part collide head like this, on part collide head equals, it's going to be find next, and then once this is over, it's going to look for on part collide, and it's going to trigger this one. So there's a hierarchy here. That means that you can actually have like subclassing your triggers. This one is going to be triggered first, then this one, then this one. If you want to stop this propagation of triggers, you can do it. It's done with a bang like this, with an exclamation point. So if I were to do this, here it means that we're going to handle on part collide head bullet, but once we're going to be doing, once we've been handling the head one, we're going to stop. So I mean that this one would fire as well, and then we would stop. This one would never be reached. And that's what we're going to do this here. Here, if you remember, we have on damage. It's going to kill our little guy. We're going to say that this time, if we collide with a box, we're going to set anim, we're going to transform. So transform, there we go. If I were to just leave it like this, when a box collide, it's going to play transform, and then it's going to trigger still on damage. I mean that it will still play its death animation and it will die. But we don't want this. When we want it to, our guy to transform, we don't want it to die after that. We don't want it to take damage. So we're just going to stop the propagation here. So if a box collides with me, this event on collide box is going to run, but we're going to stop once this one has been executed. So this one here is not going to be reached. So here we just need to define an animation transform. So let's do this. Our king here, it's a character, and the king is going to like be able to transform. So we're just going to change here. We say also you can transform. Or actually, you know what? Instead of having an animation, we can do it here. Let's say that we're going to delete ourselves. Or before we're going to create a pig, create king pig. We're going to set ourselves as a parent, set parent ourselves. We're going to detach the king pig so that they are in the same place as us. Object detach. And then we're going to delete ourselves. There we go. So basically, once we're going to transform, we're going to create a king pig. We're going to put it in our place. And then we're going to delete ourselves. So basically, we are just being transformed into a king pig. So let's create our king pig. So king pig, it's a character. And let's see what's the frame size for the king pig. It's 3820. It's tiny. I'm sorry, I cannot read. I think it's 3828. So you know what? We don't need this, we don't need this. We're just going to say 38, 28, and we just want an idle. We're just going to say that all you can do is I can do it. It's looping on idle, and the king pig idle, it's going to use a texture which is which is 02 king pig, idle 3828. And let's see if this works. Let's hit our little guy with a box. Okay, we don't see a king pig. So something happened. Oops, I killed my debug message. What did I do here? I am not sure. Let's see. Oh, king pig idle. There we go. Okay, our little piggy here, we probably don't want a body. And we probably want it to face the other way around. -1, let's see. There we go. And we could probably move it a bit to the left as well. So position, -10, 0. Yeah. Oh, and see, it stays here because it's not part of the scene. So when we create it, we should have the same thing as for the other one. Basically, get the scene ID and object set owner like this. This way, when we reset it, it should disappear as well. So let's say little guy here, reset. There we go. So now we used different collision filtering to handle damage and the box collision separately. The damage is a generic one. See, so if anything collide with us is going to deal damage, except if it's a box, because we asked the box not to propagate and trigger the generic OnCollide, which means that when we take a box, we just transform and nothing else happens. Whereas if anything else hits us, it's just going to kill us. And I mean that if I wanted to create and throw a door at the guy, he would still die because it's going to be caught by the generic OnCollide trigger, which is the one here. Sorry, it was a bit hectic toward the end. I wanted to make sure that to go as fast as possible so that we could maybe still squeeze extension and plugin because those are actually not that long. Is there any questions regarding the trigger?
I don't see any, but if any come up, we'll let you know.
Okay. So sorry again. In the end, it was a bit hectic there. I definitely thought it would be faster than that, but I guess setting all the animation myself took a little while. Okay, let's talk about extension and plugins. Those are the two main ways to extend arcs. They are like very non-intrusive. You don't have to modify the engine. You can add stuff on top of the engine. And the most straightforward way is actually the extension. When you start a new project using init, you ask for extension. Like right now, we have a bundle extension, but you can request like a cheat extension. You can request, actually it's here. You can request like the mod extension. You can request any kind of extension on top of arcs. So those work very easily. They are like non-intrusive on arcs itself, and in your game, all you need to do is call usually init and exit, and that's all you need. Sometimes you also need an update in the case of the cheat, because you need to be able to check the cheat code when they are being entered. But in the case of the bundle itself, it's only going to need the init and exit. Same thing for the mod or SNDH. Actually, you know what? Let's have a look at those guys. So we're going to add them to our project right now. So we're going to go back to arcs, and we're going to add SNDH, for example, and maybe the movie one. So it's going to keep things as is, except that now we also have the movie and the SNDH extension added to it. If we look at the extension template, you can see that extra stuff have been added for movie and SNDH. Actually, I said SNDH, but mod is probably going to be easier. It's the same idea. Okay, so now we don't have SNDH anymore, but mod. And let's look at how they work. They are very straightforward in the sense that mod exposes two functions, as I said, one init, one exit. And that's all you need to do to have this extension run on your project, even though this project will extend the audio capacity to be able to run, to be able to play Amiga mods, so also Screen Trackers module and Fast Tracker modules. So how this works? Because you still need to be able to create those on the fly, right? Like you need to be able to define those properties on an object and have this object like decode those mods at runtime. How is this working with just init? It's very simple. You have two ways of having execution, of having your code being executed during the runtime. One is by registering something on the clock, on the core clock. So that means that you can be called every single tick. That's what the cheat extension does. And in terms of the mod, it does not need to execute everything on single tick. However, it needs to know when an object is being created, and that's what's happening here. So let's go have a look. The mod init is just basically creating like a memory bank for its own use, and it's adding a handler on the object and is going to listen to prepare. So every time an object is going to be prepared, so mean that before it's been created, we're going to have some custom code run, which is our handler here. So basically here the handler is checking that we're executing an event of type object, and if it's a prepare, so here you see that an if else, because right now we only registered the events for the prepare type, but we're going to see what's happening here. If this object has a config section called mod, we're going to see if we can locate the mod and open it as a resource. If we can do this, if we can retrieve all its content in memory, then we're going to say, okay, we're good to go. Let's see if it's actually a mod that we can decode. So we're going to rely on a third-party library. In this case, it's called IBXM. And we are just going to call that function to create a module and a playback. And if everything is pitchy, we're going to modify aux so that we can actually decode this instead of any audio stream. We don't have an audio stream at the moment. So we're going to cheat and modify the config at runtime. So basically what we're going to do is we're going to request a sound list. So we're going to create a config sound list for this object before it's being created. We're going to say it's a type of music, and we're going to say that it's going to be an empty stream with 2 channels and with a sampling rate which is 48 kilohertz apparently. So that's it. We're going to tell aux once this object has been created, because we validated that it had the mod config entry inside it. We're going to say, okay, I want you to also create an empty stream of audio that's going to be decoded and run by aux like any other stream, except that there's no data in it. And because we did this, we're also going to add a few more event handler. We're going to add one on the object, and this time we just want to listen to the delete object, so that once the object delete, we want to stop the playback and like free all our module data. That's why there was a else at the beginning of this event handler. So now we can be either prepare or delete, and we can see that if we receive a delete, we're just going to stop playing the music on it, and we're going to remove our event handler and delete our mod. And the second event handler we added, it's a sound one, and this time the sound one is just for the packet type, which is here, which means that every time an empty packet has been generated because we need to send something to the audio device, we're going to intercept that packet and we're going to fill it with samples that we've been decoded, or like samples that we've been populating through the decoding of the mod, and we're doing this on the fly. So every time this packet is being received, so we see that we created a function, we hooked a function called aux mod decode. Every time a packet is empty and arrives, we are just going to verify that the object is enabled and not paused, otherwise we don't want to play the audio there. And then we're going just to ask the third-party library to populate all those samples for us. Once it's done, we're just going to say how many samples have been added to that packet, and we're going to send it back to aux, and aux is going to play it. And this way it's going to work in any in exactly the same way that for any other type of audio, which means that if you add a clock to this object and you want to do some time stretching, slow it down, or make it go faster, the pitch is going to be changed as well. It's going to be like slowing down, like lowering the pitch or increasing the pitch based on that factor, even though that the audio has been generated outside of aux and just hooked inside aux. So One way for extension to be able to execute code at runtime is by adding event handler for the kind of event you want. Most of the time it's going to be object creation or object prepare and object delete. Or if you want to run like every single time, you just register yourself to the core clock and you're going to be part of the core execution. So this way you can have like code executed on top of Orcs without having to modify Orcs itself by either leveraging the events or by leveraging the clock system. That's how you do it with extension. Plugin, it's a bit different. Plugin, you can, well, actually, one of the most famous plugin, when you build Orcs, there is Bounce here, which is my little playground. And Bounce is a plugin. Then a plugin is basically a DLL or like a dynamic library that you're going to be able to load at runtime whenever you want. And now you will be able to also hot swap them and remove them. This is very recent. It's something that's been added in the last couple of weeks, I think. And the way it works is that you're going to have to define one entry point. Again, a single entry point. And in this entry point, you can register two event handlers. You can add clock callbacks, which means that you can have a lot of things going on. And the way to declare the entry point is with this macro, Orcs plugin declare entry point. And this function here is going to take a parameter, which is the mode of entry. The mode of entry can be either init, meaning that it's the first time you were loading your plugin, you receive init, you're going to create your things in it. It can be exit, which means that you're going to exit from your plugin, and that's where you should free all the resources you're not going to use. But there's also two other modes. One is called swap in, the other one is called swap out. And basically, it's when you are going to hot swap a plugin. So we're going to remove the plugin during the swap out, which means that you need to initialize anything that you don't want anymore, or you want also to write in the config things you want to retrieve for later. In the case of bounce, here, in the case of swap out and exit, we're going to unregister all our event handlers, our clock callbacks, but if we're exiting versus swapping out, we are not going to do the same thing for the things we created in the init. So that if we exit, we're going to delete our worlds, we're going to delete our spawner, and we're going to delete our viewport. That's fine. However, if we're swapping out, we want to keep those objects. They are living inside Orcs, and we want to keep them in the state they currently are. So what we're going to do is we're basically just going to store their GUID in config. So here, as you can see, we're just going to call orcs_config set u64 for the ball spawner and the walls, and we're going to store their GUID, and we don't define the section there. There's actually a very specific section that's going to be pushed for you when swapping out, and the same section will still be pushed for you when swapping in. So you can use that config section as a temporary storage. This config section is going to be erased entirely when the hot swapping is over. If you want to do more permanent config modification, you can do it. But by default, you have this temporary section that's available to you. So here, if we're swapping out, we're going to keep the GUID of the ball spawner and the GUID of the walls so that the objects remain in memory, they remain in their current state. We just want to make sure that we can retrieve them when we're going to swap in. And if we look at the swap in, the difference between init and swap in is that in init we create everything, except that in swap in, instead of recreating the spawner and the walls, we're just retrieving them from the config, and we update our pointers to them, and then we'll register again all our event handler and our clock callbacks, and which means that you can unload and load the plugin at runtime. And let's have a demo here. You can, I'm not sure where there's oh yes, because I modified that was to answer someone's question on recently. So there's a little red square that comes from the bounce alt, but you can see that the bounce plugin the same as usual. And here now I can say plugin unload bounce, and up, everything is gone. And I can reload bounce, plugin load bounce, and you can see that this time it's created again, which means that you saw all the walls being created again. If I do load like this, it's going to go through the exit and init. It's not a hot swapping. However, if I wanted to do hot swapping, it's completely doable. And for this, actually, I'm going to show you, where do I have it? Here, code bin. Here we are inside the bin folder of Ox. You can see we have a bounce shadow 002 DLL, and the shadow is only used as a local copy, just to make sure that you can modify the source DLL, so that this way, if you're working on your plugin, which is a DLL, you can still compile it again when Orcs is running, because we don't keep a handle on it. All we do is that we use it as a resource. It's just a resource like any others now. If that resource has changed, we're going to pick it up, and we're going to create a new shadow copy that we're going to actually load inside our execution. And we can mimic this by like modifying the modification date of this. So let's actually do it here. Command line. I have touch. Oops. This. We're going to touch. It's inside plugin demo bounce DLL. If I do this, normally we should see the bounce shadow count here, okay, being updated. So if I touch this, oh right, there you go. See, a new version has been created, and here you can see that the walls were not created. So basically, we did the out swap. We went into swap out, swap in, and we keep the same wall and the same spawner, and even though we picked a new version of the DLL here. So because now there are resources, which that means that if you have a plugin, you can also compile them and embed them inside a bundle. You can have your DLL inside a bundle, and you can run it as any other thing. So that's the last thing we're going to test today. It's not going to take too long. So let's actually go back to this project here. Little guy here. And we're just going to remove the entire scene. We're not going to create anything anymore. Why are you scene? Yeah. So if I run this, now it should be black. There we go. Nothing here. So we're just going to load the bounce plugin. So in order to do this, all we have to do is copy bounce in our live data. Sorry. So we're going to put it in the bin here. We're going to copy all the resources we need for bounce, which are, where is it? I close the windows. Of course I close the windows. Okay. Workspace, Orcs. Okay. So here we need to take code, bin, and we are going to copy the plugin, bounce. Okay. So we need the plugin, and we need also all the resources for the plugin, which are in data, bounce. I'm just going to dump them here. I could put them in the texture folder, but doesn't matter. And the last thing I should not forget is that we also need the config for bounce, and it's these two files. Okay. So now I have everything for bounce to run inside the live example here. So if I run live, and I say plugin load, bounce, and we crashed. What did I do incorrectly? Oh, get idea, load, what's going on here? Resource location. What do we have? Oh, it's final bounce.ini. Oh, wait. What do I have in that config file? You know what? Just to make sure, we're going to delete everything here. And bounce. Okay. I'm going to remove the red box. Let's try this again. Oops. Plugin, load, bounce. Oh, yes, I'm running the debug version, but I didn't copy the debug bounce plugin. So let's do it with release. I'm pretty sure that's the issue there. So plugin, load, bounce. There we go. And we have bounce running in this new project. It loaded the DLL, and that's it. So as you to show that it's actually a resource like any other resource, let's try to bundle it. So if I were to bundle the game right now, if I run it, you see that it will find almost like nothing in the bundle. Like, yeah, it found .ini. It's because it doesn't know that we want the bounce one. So here, if we go into the beginning of, in the init of our live, we're going to remove that log. We're going to remove the scene, and we're just going to say arcs plugin load bounce. If I do this, and we can actually say only do it if we are actually bundling this processing. Now it's going to be found. So running it now should tell bundle to be able to find not only the bounce DLL as a plugin, but also all the config that goes with it. Except that I made a little mistake here. I did not tell that where to find a plugin. By default, it's only going to use the local folder. So we need to say that the plugin can also come from bundles, like this. So let's rebundle this with a new config. Okay, so now this works here. Let's see if it actually worked as intended. We're going to create a new folder, test. We're going to copy our live 14 release, our bounce DLL, and we should not, oh, actually, we don't need bounce DLL, we need arc DLL, sorry. And the live 14 bundle, which is this one. If we go here and copy this, it should still be working. By default, nothing happens because remember, we're not executing it by default. But if I say plugin load bounce, up, you can see that the shadow copy has been created. It's been extracted from the bundle itself, and it's been running. And if I were to unload it, now it's the shadow copy has been removed, and the bounce DLL is still inside the OBR. It would be the same thing. We can actually pack everything inside the executable, like any other bundle, put it in memory. It would work the same way. So now you can actually write plugin, compile them as DLL, and have them embedded in your bundle and loaded at runtime. And this work on all platforms except iOS, which will not allow you to do this. Yeah, so that's the two ways of extended arcs, with extension that you will compile at the same time as your code, like everything that ships within it, or as plugin that you can load at runtime and that you can package in bundles, and you can hot swap if need be during development. Is there any questions?
We might have one. Hold on.
Yeah.
Is this shadow copy thing supported on Windows when running in isolated storage, i.e. UWP apps?
I am afraid I am not knowledgeable enough to know about this, so my answer is I do not know. I don't know anything about isolated storage. Also, the shadow copy only happens on Windows during debug. Other platform actually allows you to bypass the shadow requirement. However, when loading from bundle, the shadow copy will be created no matter the platform. And for the question, unfortunately, I do not know anything about this, so I cannot answer. So as long as you can load the DLL from the same folder, it should work, question mark. But again, I do not know enough about this. Any other questions?
I don't think so, but as a reminder to everyone, if you have any questions or anything, you can always ask them within the Discord when we're not in live events.
Excellent. Well, thank you so much, everyone. And yeah, and that's it. Thank you for joining us. And if you have any questions later, please ask them in the channel. Otherwise, I wish you all a good start of your week. Bye, everyone.
Bye. Thanks so much.